All right, guys, the next set of notes, we're going to talk about angles outside of a circle. We talked about central angle. We talked about angles inside the circle when we have two chords, and we have that formula. Now we're going to talk about what happens if we have angle outside. It's a lot like the last formula with the angle inside. But let's first review on a tangent segment. We never really defined the tangent segment, but we have seen it. It's going to be a segment that is tangent to a circle at an end point. So what ends up happening here is your tangent is here from S to C, but your tangent segment actually stops right here at C. So that's the segment we're going to be looking for here. And I guess we can go ahead and name as we're going through here. So down here we have just from S to C. It stops right there at C. We have segment SC. Then you are going to have your secant segment. Secant slices through. So your secant segment is it's a segment that contains a chord of a circle and has exactly one end point outside the circle. So when we take a look over here, we have our other line over here. We've got our chord, but it does go into slicing the circle, including this chord. So it's going to be this entire segment right here of segment S all the way to A, because we have to get, if we just stop at N, we just have a segment. We have to slice into the circle. That's the secant slices. So we have segment SA, not SN, not NA, segment SA. We want to know where the vertex is of angle CSA. Well, we've already learned that that middle letter is where the vertex is, so it will be at angle S. Okay, it'll be right here. So now we want to review. We've got two different arcs here. We're going to have a smaller and a larger arc, so we will have a minor arc and a major arc. Here we'll name the two arcs. Well, the first arc is right here, okay, closest to the vertex. And we don't need that E. We need the two endpoints because it's going to be our minor arc. So we're going to have arc C to N, or you can call it arc NC. Do not include the E. It has to include the C and the N where it starts and it stops, starting at a tangent, ending at that secant segment. Or it could be two tangents, could be two secants. We'll be looking at these, okay? In this case, because we have that tangent, I said major arc and minor arc, we'll be looking at different examples. We might have two minor arcs. But here we're going from segment C down to, point C to N. So we have arc CN. And then our last arc is going to start with the C, but this time, because we have that secant segment, we're going to end at A. Okay. Right now, we don't know the measurement, so it looks to me like it's over 180 degrees, so we're going to go ahead and say it's going to be a major arc, so we'll call it arc CLA, or the other way, arc ALC. Remember that our endpoints with that point that we pick up L in between them. All right. Now, of course I forgot my highlighter, but when we have this angle that is now outside, this vertex is outside the circle, okay, the measure of the angle, that's what we're looking for, is going to be equal to half the difference between the two arcs. So what your formula is going to look like, and it's usually just arc 1 minus arc 2 divided by 2, but we're going to be more specific. We're going to take the big arc, subtract the small arc. We do not want negative numbers. So big arc, we'll have measurement of the angle is equal to big arc minus the small arc, all divided by 2. So it's a lot like in the circle, but now we're subtracting instead of adding. It is very, very specific which arc has to go where. So let's take a look at our first example here. We're going to solve for the measurement. We're going to solve the measurement of angle FRT. So right here, so we're going to have our measurement of our angle that we don't know. We're going to take our big arc, which is, well, between 50 and 140, pretty easy to see which one's the big arc, that 140. We're going to subtract the small arc, 50, and divide by 2. When we take 140, we subtract that 50, we're going to get 90 divided by 2. And 90 divided by 2 is going to be 45. So we have 45 degrees. That's all we're doing. Subtract, divide by 2. Go back and watch it again if you need to, please. Okay? Now we're going to come across a situation where we have two tangents, okay? And we're just going to use a tangent sequence, just stopping right here. But with the two tangents, what you have to do a lot of times is you realize they're only going to give you one of the two arcs. Because we know that this part of the arc, the small arc, the minor arc is 150, all the way around is 360. So we can find the major arc. We just have to take that 360 all the way around. When we have two tangents, nothing goes in, neither one of these slice in two. So we're going to take that 360, we're going to subtract the 150, okay, subtract that 150, we're going to find out that the measurement of this major arc is 210 degrees. Now that we have this, we can use our, put big arc minus small arc divided by 2, okay? So we're going to take the big arc, the 210, measurement of the angle is equal to big arc 210 minus the small arc. If you get a negative number, you know you did something wrong. You just switch these numbers around, okay? Big minus small divided by 2. If we take baby steps, 210 minus 150 is going to give you 60 divided by 2, which is going to give you a total of 30 degrees for that angle. So just like within the circle, out the side of the circle, you're also going to have to work backwards at times, where I'm going to give you the angle. So you're going to have to work backwards. Where you're going to have to see where x is going to go. X cannot go first every time. And that's what's going to happen on this first one. You will have to deal with a minus x, and that's what's going to happen here. So let's take a look here. We have the measurement of our angle. Okay, I'm just going to go ahead and rewrite the formula. The measurement of the angle equals big arc minus small arc divided by 2. Well, we have the measurement of the angle, which is 40. We're going to set that equal to the big arc is going to be the furthest away from that angle. Bigger distance from the angle, from the vertex. So the bigger arc is always the biggest distance away. So that 150 minus the small arc is always the smallest distance from that vertex, minus x, divided by 2. Now, we talked about this in the denominator. There's 2 in the denominator. All we need to do here is we need to get rid of that 2 first, exactly like we've done before. Multiply both sides by 2, so they cancel out. 40 times 2 is going to give you an 80. And now all we have left on the right is 150 minus x. So you have a couple options here. You can go ahead and you can get rid of the 150. I'm going to show you that so you can see what happens if you have a negative x. So if I subtract this 150 from both sides, you will end up with a negative on the left, which is okay for now. You're going to get a negative 70 because this is going to be equal to negative x. And so to get rid of that negative x, all you're doing is you're dividing by a negative 1 to cancel that negative. Divide by a negative 1, and now it cancels these negatives. Moves over here. X is going to be equal to just 70. So you just need to take the negative. Once you get down here, if you have a negative on both, just get rid of the negative. Okay? Now, what I'm going to do is I'm going to show you an alternate way of doing it if you go the other direction. Okay? Here, let's set this up again. 40 equals 150 minus x divided by 2. Pause it. All I did was reset the equation up exactly like this. I'm going to show you moving the x instead. Let's go ahead and multiply by 2 on both sides. It's always going to be the first step here. And slow it and rewind if you need to. 80 is now going to be equal to that 150 minus x, just like we had over here. Okay. Now what I'm going to do is I'm going to add x to both sides so I don't have to deal with negatives. The problem is this x and 80 cannot combine. So now we have x plus 80 equals 150. And now we just have a regular one-step equation. So you could do either way that you would like to. I want to present you with both because I don't know which one's going to work best for you. So we subtract that 80. Bring this over here. We still get that x equals 70. We just didn't have to deal with the negative on that one. Okay? If the bigger arc is x, easy peasy. You don't have to deal with that minus x. Okay? Now, so what happens if we have a bunch of algebra? The exact same thing. Nothing changes. We still take the big arc, or we'll take the angle measurement. We'll write this down again. Measurement of the angle equals big arc minus small arc divided by 2. Well, the measurement of my angle is x plus 25. So we'll fill in x plus 25 is equal to the big arc, biggest distance from the vertex, 4x plus 5. We're going to subtract the smaller arc, smallest distance from the vertex, 50, all divided by 2. Now, we cannot do anything with that 2 in the denominator just yet. We have to combine our like terms up here. And up here, I see a positive 5 and a negative 50. So basically, we're taking 5 minus 50. We're going to have a negative here. Bring down this x plus 25. Nothing changes there. Our 4x is nothing to combine with. 5 minus 50 is going to give me minus 45, all divided by 2. Now it's time to get rid of that 2. Okay, we cannot do anything with the x's or the 25, the minus 45, not until we get rid of that 2. So let's go ahead and multiply both sides by 2. Okay, get rid of that. Now what is going to end up happening here is that we are going to have to distribute. Okay, I want you guys to see here. We're going to have to do 2 times x. We're just used to having the parentheses right here. If you'd like that, that's fine. So we're going to want to 2 times x. We're going to get 2x. We distribute 2 times 25, a positive 25. We're going to get plus 50. On the right, all we have is that 4x minus 45 now. So now we have 2 steps, or we'll get more than 2, but variables to one side, constants to the other. Okay? Subtract the 2x from both sides. I like to move the smaller one, like I always say in my videos. I'm going to bring down that 50 equals, well, 4x's, I take 2 away, I have 2 left. And then bring down the minus 45. 2 steps left. Let's get the constant. We'll move the variables to the right. Let's move the constant to the left. How do we do that? Well, it's a minus 45. Well, let's add that 45. So we can cancel those out. Do to one side, we do to the other. 50 plus 45 is going to give me 95. Bring down your 2x, and then simply divide, and we are done. We will get a decimal. I was telling my students we will get decimals in this unit. X will then be equal to 47.5. We do that division. Okay, so you've seen it with the algebra as well. So we are now, the angle is outside of the circle, so we're now going to subtract the arcs and divide by 2.